Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all. In today's lesson topic, we're going to be looking at specifically vertical motion within the quadratics unit. So before we jump into today's video, please make sure to do four things. Make sure to smash that subscribe button, hit that like button, turn on post notifications, and also feel free to leave a comment down below. So in this lesson, we're going to be looking at what exactly vertical motion is, how can we represent it through a formula, and how is it related to quadratics. In recent time, throughout our Algebra 1 course, we've been focusing on quadratics specifically, like our vertex form, our standard form, and just the basic of the quadratic function. And now you might be thinking, why am I throwing in this random vertical motion video? What exactly does this have to do with quadratics and parabolas, essentially? Well, vertical motion is a very realistic and real-life application scenario, and I'll explain it in more. So, vertical form or vertical motion. What exactly is a vertical motion? Vertical motion is the mapping of the elliptical movement an object takes when it is thrown due to gravitational force. So if we think about any object taking flight in an irregular flight pattern, normally you would have some slopes or bumps overall, but when you're mapping the general flight, the mapping of the flight itself, you're taking off from a starting point, and then of course you're landing out at a landing point. You're going to be fluctuating in height, but a better example would actually be throwing a ball, essentially. So, for example, when a ball is thrown into the air and you're literally launching that ball right out of your hand with a significant amount of velocity, it will take a vertical motion and a path that is similar to a parabola due to the force of gravity gradually pulling it down. So when you throw that ball, it's not going to go straight up and straight down, essentially, unless, of course, you're throwing it in a specific manner that drops, straight down. But of course, when you're throwing it, it's going to have a parabolic shape, essentially. You're throwing it up, and then as soon as you throw it up, it doesn't just spike downwards. It starts to slowly and gradually curve downwards. And that's because of the pull of gravity slowly getting stronger, essentially, as that ball starts to fizzle out with its initial velocity. So that essentially maps a parabola. And with that parabola and with this whole property of vertical motion, we can create a formula for vertical motion. So like I said, vertical motion can also be mapped by a specific equation that also represents a parabola. So literally, if you graph it out, it represents a parabola just like standard form equation. It has the same exact three distinct terms, just like a trinomial. And it involves the initial height of the object that's being thrown. So for example, the ball, it involves the initial height, the time of the flight, so the whole entire duration that it takes, and the height throughout the entirety. And also, obviously, it'll show you velocity, which is a combination of these different characteristics and properties. So let's take a look at the features of this standard form equation, essentially vertical motion being a standard form equation. Let's take a look at this standard form equation here, the different components and the variables. So this is the vertical motion equation, a type of standard form equation that is h equals negative 16t squared plus vt plus s. So this might be quite confusing, but let me break it down for you. So h over here on the left-hand side is what we're always calculating for isolated. Just like your y in a regular quadratic equation, we're calculating for the height of the object at any given time. So that's the height. That's what you're calculating for. And obviously that can be in any regular measurements, meters, feet, inches, whatever height that you're going to. And then, of course, our negative 16, it's going to be multiplied with t squared, which is time squared at any given time. This is just a specific property that gravity has, so you're always going to be multiplying negative 16 to t squared, which is just scientifically proven. It's just a scientific property. And obviously, t squared is time squared, t being your time. And then, of course, v, on the other hand, is going to be the initial velocity of the object, essentially, when it's being thrown. How much velocity does it have? Velocity is just speed with a given direction. And that's going to be a distance over a period of time, like meters per second, meters per minute, so on and so forth. And then, of course, t is just merely time at any given moment, just like our t squared. And then, of course, s is the initial height that it's being thrown at. It's being added as a separate constant. So now let's take a look at trajectory problems that has to involve with using the y-intercept. This is really what vertical motion is, and this is what we looked at in the previous video. So oftentimes with trajectory problems, you're going to come across these problems, which is when something is thrown or takes flight at an elevated height. That's why you always have an initial height in your vertical motion equation. So you can calculate for the starting point by using c, which is the y-intercept, just like as shown in the standard form equation. It's going to be that initial height that's already given there, s. And then, of course, the maximum by using the vertex. So once you graph out the parabola, I wouldn't recommend using the equation itself. It's easier to graph out the parabola and identify where the maximum is. And then, of course, the landing point with the equation, where the height equals 0 is where the landing point will be. So this is the general example of what that might look like. It's an irregular flight pattern, maybe due to facts such as wind, or just an irregular flight that an object might take because it's not equally distributed in weight. But things like that, it essentially creates a general shape of a parabola, a ball being thrown. So when it creates that smooth parabola, you're going to have a starting point. You're going to ignore everything in the negative side. You're going to have that starting point in your hand. It starts at an elevated height, and then, of course, it lands on the ground level. You're 0. Essentially. And that's what we're going to be calculating for. So let's do some vertical motion practice. Let's take a look at a problem. So in this problem, a ball is being launched off of a skyscraper that is 40 meters high with an initial velocity of approximately 12 meters per second. How long will it take for the ball to hit the ground, assuming it will hit ground level at its trajectory, so 0 meters essentially. So let's take all of that information that we have and let's plug it into our equation, what we're given already and what we're trying to solve for. So let's solve the problem. So we're given this equation here. And remember, the original equation was h equals negative 16t squared plus vt plus s. Our 0 on the side here is going to be our height, essentially, our height. We're looking for 0 meters when the ball is going to hit the ground from the skyscraper's window. So 0 meters. And then, of course, here, it's negative 16t squared. That's essentially what the time squared, that's the regular property of it. And then, of course, you can see here we added in the 12. 12 was the velocity, and it's actually 12 meters per second. And that's going to be our velocity, our initial speed that it's going to be starting when it's dropped from someone's hand or thrown from someone's hand. And then, of course, here, this added 40, this plus 40, it's going to be our starting height of 40 meters. So starting at 40 meters high. So now that we've identified all the parts that we have here, we're merely just trying to identify what the time is, how long it's going to essentially take for this ball to hit the ground in seconds. So now we've plugged in how much we need for our height, 0 meters, our velocity, 12 meters per second, and our starting at 40 meters. All right, so now we're going to calculate for this equation here. We're going to calculate to isolate for t, time, to get the value of time itself, how long it's going to take for this ball launched from the skyscraper to hit the ground. So we plugged in everything that we need, and now we're going to solve for t. So the first thing that we're going to do here is we're going to isolate t, essentially. So the first thing that we're going to do here is we're going to factor out the right-hand side of our equation. Factor out as much as we can from that right side to make a smaller condensed equation. So we're going to put 0 on this hand side. And then, of course, we're going to factor out our negative 4. Negative 4 is the largest factor that fits into each and every single one of these numbers here. So let's factor out negative 4, our greatest common factor. So negative 4 here. We're left with 4t squared minus 3t minus 10. So once we factor that out, the next thing that we're going to do is, I put 4t cubed. This should be 4t squared. So now that we've factored this out, essentially, what we need to do is we need to do factor by grouping, essentially. So the property that we're going to do is we're going to try and factor this out into 2 separate binomial factors. This trinomial, split it up into 2 binomial factors. So the way to do that is you're going to take your starting term, your first term, face value, that coefficient, and the last term, and you're going to identify and you're going to multiply these together. So 4 times negative 10, that's going to be negative 40. So essentially, we need to create 2 terms that are going to multiply to negative 40 and are also going to add to the middle term's face value, negative 3, that are also going to add to negative 3. So we can start to look at these 2 values here, negative 40 and negative 3. So what's going to multiply to negative 40 and add to negative 3? Well, I'm going to save you some quick calculation here. It's going to be negative 8 times 5. That adds to that multiplies to negative 40, and then negative 8 plus 5, that adds to negative 3. So now that we've calculated that out, what we can do is we can advance our equation now. we know that we have this -4 here being multiplied. However, the -4 can get eliminated because we can divide it by both sides of the equation, -4t and -4t. And when you do so, the -4t cancels out because 0 divided by -4t is 0. So now we're left with this equation here, this little trinomial here. So what we're going to do is we're going to take these factors. We have -8 and essentially 5, and we're going to split this up into two separate parts. So we have 4t squared, and remember, it has to add to -3t, but also multiply to -40. So it has to be two factors of t, or two multiples of t. So we're going to make this a -8t here. And then also on this hand side, we're going to add this together, split this up into two separate binomials that we add together, and we're going to make this 5t minus 10. So that's essentially what the property is. Let me clear this up for you. So these are the two binomials that we're actually left with. 4t squared minus 8t plus 5t minus 10. And then we're going to factor these out separately, so get the greatest common factor from these two as well. So we're left with 0 equals, so we can factor out a 4t from this binomial here. So 4t, we're left with t minus 2. And then of course on this side, we can factor out a 5. So we're left with 5 times t minus 2. All right, so now that we've gotten the general factor of t minus 2 as our factors, essentially, we can actually plug these, right? We can actually set these equal to 0. So t minus 2, we can set this equal to 0 here. So t minus 2 equals 0. Because this is one of our factors here, we don't have to go on further to calculate what our other factor might be and set that equal to 0. Because if t minus 2 equals 0 and that works, then we're going to stick with t minus 2 equals 0 and see if it's a reasonable amount. So that means that t will actually equal 2. So 2 being the amount of essentially seconds that it takes, that means in this situation, it's going to be a little bit over 2 seconds, approximately 2 seconds, that ball, when launched into the air, is actually going to hit the ground. Obviously, this is a little bit different when it comes to the standard amount of time that it takes to hit the ground because the velocity is so high. Remember, I said it wasn't thrown. It's actually being launched because the velocity is super high in this case. It's actually going to hit the ground in literally 2 seconds because of the pull of gravity. So it's going to be more or less a lot faster than your average throw of a hand. So in this case, it's being launched, so it makes it a lot faster. So it's only going to take 2 seconds in this case. All right, everyone. Well, I hope you guys enjoyed this video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below, and check out our website at www.ecoreacademy.org. Feel free to email us at eCoreAcademy@gmail.com, and check out all of our socials at Pinterest, Facebook, Twitter, Instagram, and TikTok. See what kind of interesting content we have out there, and make sure to share all of our videos. Once again, everyone, this has been AJay Raj. I hope you all enjoyed this video, and I'll see you guys in the next one. Peace.